a few more people. Come on up to the front. Have them come to the front. Come right up. Thanks. All right, ladies and gentlemen, welcome. I can feel the coding excitement in the air. I know that some of you are not yet with Choreograph loaded, but don't try to do it as I speak right now. After the program starts, we'll come around. We have about 4 of us that will come around and help you if you don't have Choreograph loaded. If there is a problem, you were coming tonight with Choreograph preloaded. So if there is a problem and you can't get it loaded, maybe you can watch what's happening and you can see how Python works within Choreograph. And then when you come to another class here at the library, we can work on filling you back in with things that you might miss tonight. I'm Bill Derry, and I'm the Director of Innovation at the Westport Library. And it's really a pleasure to welcome this many people to our Hour of Code. Tonight, we have the presenters, the initiators of the Hour of Code, Aldebaran Robotics, who are with us to present Python, but a special version of Python. It's Python within the Choreograph software that is used to control the NAO robots. How many of you have taken a level 1 course? Raise your hand. Whoa! A lot of you, great. You probably know that we start level 2 tomorrow, and level 2 classes are on the website, and you need a level 2 class if you're going to be involved in the competitions. In January, our first NAO competition will be writing a poem that the robot will act out with gestures and sound effects. In February, we're going to do short stories. In March, you're going to do a dance. And in April, we're going to have a public service announcement, leading up to our Maker Faire on April 25th, where we're going to see a grand finale of the best and see the final winner of the coding contest at the library. So you need to know a little bit more about Aldebaran, because it's Aldebaran that's providing the service tonight of the Hour of Code. They have already sold 6,000 of the robots around the world, and we are the only library that has them. So we're still the only library, as far as I know, right, that has the robots, and that where we're teaching people how to use them. The NAO robot has brother and sister named Romeo and Pepper, but we're just looking at the NAO tonight. And it's a humanoid robot that helps people understand how robots really work, and it makes them less of a mystery. It also teaches coding. That's why the library has them, to teach and to learn and demystify what robots are. Now tonight we have 2 presenters. We have a primary presenter and we have the person who introduced the NAO robots to us. So I'm going to introduce these 2 people. We have Mandy Dwight, who is the academic sales manager for the U.S. Northeast at Aldebaran in Boston. And she's a worldwide, well, she actually represents the company, which is a worldwide leader in humanoid robots for better living. She used to be an educator and an administrator in schools. So she advocates for the use of cutting-edge technologies and project-based learning to engage students as active participants in cross-curricular classroom settings. Currently, Mandy promotes social robots, such as NAO, as a way to enhance career readiness. Like, we think that if you learn about these, it's helping you, no matter what your age, it's helping you with possible new career opportunities in the future. And that's what Mandy brings the robots to organizations for. Then we have our presenter today, Jack Grannan, who actually trained us on the use of the robots. And he's the field application engineer for Aldebaran Robotics in Boston. He's actually a mechanical engineer. He was trained at Case Western in Cleveland, Ohio. He also has a master's degree in mechanical engineering from the University of Cincinnati. And he successfully converted a manual mobility scooter into a fully operational robotic scooter. He was a controls engineer at Belkin for 3 years, testing engines. He's very passionate about STEM education. Everybody knows what STEM is, right? science, technology, engineering, and math. And he promotes STEM education, and he started his own company. And the library is really about entrepreneurs and people who do start their own companies. Maybe we have 5 or 6 young ones out there, or older ones, who are about ready to start a new company. That's what the library is supporting right now, entrepreneurs. And we hope you are going to be entrepreneurial. So while as a student he started that company, but now he travels around and he brings his technical expertise to integrating the robots into classroom adventures. And this is like a giant classroom. The library is a giant classroom, and here we all are on the adventure. Could you all join me in welcoming Aldebaran for the Hour of Code, Mandy and Jack, to the Westport Library.
Thank you, Bill. All right, so I want to extend a thanks to Bill and everyone here at the Westport Library. They've been incredible in getting us involved and getting all of you involved. This is the biggest seminar I've given, probably by about 30 people, so this is gigantic. And seeing how many people of you have come out here voluntarily to spend your evening learning coding, that's incredible to me. As Bill said, I'm passionate about learning, about teaching. You know, I've always been interested in engineering, STEM education. But when I was growing up, we didn't have anything quite as cool as this robot. So when I went to school, you know, it was all text-based coding, text-based learning. It got the job done, but it wasn't as grasping. And we didn't see classrooms nearly as full as this. So I think this is a great product. I think it's a great piece of technology that is not only useful in accomplishing its goals in teaching you, but it's also engaging. It's getting all of you to come out here to spend your evening doing this. So I want to thank all of you for being here. And with that, I want to get right into it. Can we switch the display? All right, so this is our software Choreograph. So not only do we make the robot at Aldebaran, but we created a software that allows you, the user, to use it more efficiently. And so this is the general interface for it. Many of you already have it based on the hands I saw raised for who has done the workshop. If you don't have it, don't worry. I think they're going to come around and help you figure it out. But we're going to get right into it because we only have an hour. We're going to make sure we teach you as much as possible. So just to kind of run it down, this is our box library. On the left here, it basically lets you pull out commands to do for the robot from a pre-programmed library. So instead of having to program the robot to say hello from scratch, you have a box that lets you do that, to have the robot stand up, to have the robot wave. These are all things that you can do automatically, so it's not as intimidating when you get into it. The center area, this is the programming interface area, so when you create behaviors, you're actually creating them in this middle space, this little gray area. And so we're going to actually see how we do that in a second here. So right now, I'm going to show you how to connect. So if you're following along, in Choreograph, many of you know that there is a built-in virtual robot. So you can connect. And if you connect to a virtual robot, it pulls up a little model. Make sure this is still on. Yeah, it doesn't seem to be updating here. Okay. Which one was that? Just okay. Okay, so when I connect to the virtual robot, basically it pulls up a nice little view here. So I can manipulate this, I can move it around. And this is nice because even if you don't have a robot, even if you're working independently from that, you can still program and use Choreograph as if you had the robot. Obviously, you're going to lose out on some of the functionality, but it's going to be a good programming experience. So when you're, sorry, do we have a question? No? Was there a question over here? Okay. Yes? Yeah.
I have a comment to say. I'm getting this robot that's very similar to these type of robots, and it includes it being able to program it.
Is that a question? Okay, that's good. Now I'm glad that there's all sorts of robots out there that are doing this. Not just us. I mean, was there another question? Or are we gonna? Okay, great. All right, so this is the virtual robot. What I'm going to do is I'm going to connect to my robot just so you guys can see something. So, I'm sure I'm super interesting and all, but you'd much rather hear from a robot, right? So I'm going to go ahead and connect to my robot here. Robot's name is Ruby. And so when I connect, it shows you the robot here. So the robot is sitting down. You can see it on the virtual view. The robot is also sitting down. So the reason this is like this is because the robot is in tune with the computer. So when I'm sending commands to the computer, the robot's receiving them, and vice versa. If I raise the robot's hand, it raises in the program. So there's sensors that let the robot interact with the computer, and that's why it's really a useful tool for integrating with the computer. So first thing I want to do, if many of you have been introduced into a programming course, you'll know the first thing you do is say hello, or hello world. So I'm going to have that happen, but with the robot. So first thing, I'm just going to do a brief introduction here. So here's a box that I'm dragging from the library, and I'm going to create a line from the start to the play here. So this lets the program know when it starts that I'm going to have the robot say something. And then when I want the program to end, I'm going to drag this and send it to the end. So if I double click inside here, I can set my text. I'm going to leave it at hello. So I'm going to go ahead and hit play.
Hello.
So let me get the mic on so you can hear the robot for those on the stream. So basically, there's two things that are happening here. The robot is getting sent a command, but also we're able to see visually how the code is being run real time. If you follow the strings along the top here, you'll actually see the code start from the play button here. It's going to go into here, which at that point the robot will then execute saying hello, and then when that's finished, it's going to send a command here to the end to then stop our code. So I'm going to go ahead and run that again. Now try to visually follow along, and I'm going to make sure the robot is heard here.
Hello.
And one more time just to make sure we see it. So you can see the green line follow the pattern of events here. So that's a really basic way of doing that. Now, you might be wondering, what does this have to do with Python? And that's a good question, because right now we're just using boxes. But what the nice thing about this program is, not only are you able to intuitively program the robot using these boxes, but you can also see what the boxes are made out of. So if I click inside this, I get a combination of other boxes. And what this is the makeup, the structure of what is inside that box. So inside the say box is two other boxes, and this is the code that makes those work. Now that's still not Python, but when I click inside one of these, it pulls up what we call the script editor, and the script editor will actually show you the back-end code for this. So this is all in Python. So I can actually scroll through this, and I can see exactly what the code is that's making the robot say hello. So instead of starting from scratch and saying, well, I don't know anything about Python, you can kind of use this information. You can program the robot using these boxes, figure out what you're doing, figure out what the robot's doing. It's very easy to articulate exactly what's happening. I want the robot to say hello. I can hear the robot say hello. So I know it's doing that task. Now, what is the code that's making it happen? This is where we get into that. So we're gonna come back to that in a second. We're gonna close out of this. Let's do something a little more advanced. We want to have the robot not just say hello, but we want it to wave hello. You know, what good is saying hello if you don't have an action with it? So we're gonna go into our, again, back to our box library. We're gonna go to animations, in motions folder, and pull out the hello wave. Now, for each of these boxes, you can mouse over the description and see what it does. Since we only have an hour, I'm not going to focus too much on that, but I just want you to know that if you're curious about what anything does, there's a pretty good description inside the boxes there. So this, it says it's a simple hello animation, and it just lets you know there's no speech in this box. So if you want it to have speech going along with it, then you have to program it to do so. So we're going to do that now. We're going to have the robot say hello, and then once that's done, we're going to have the robot wave hello. So we're going to draw a little connecting string there, and then when the robot's done waving hello, again, we're going to end our program. So again, if you want your program to start and stop organically, you're going to want it to start here, and when you press the play button, your program is going to start and send a signal from here to everything it's connected to. So right now we're connected to a say box, which is then connected to a hello box, which is then connected to our stop, which will then end our program. So let's go ahead and test this. Again, feel free to follow along visually. So you can see the robot waving hello, and you can see the virtual model that's also doing the same thing. We're going to play that one more time.
Hello.
Isn't he friendly? Okay, so that is what we call some sequential programming. We're going from one piece of code to another to the stop. So let's say we like that, but we want to do them at the same time. We want the robot to wave hello and say hello at the same time. This is what we're going to get into called parallel programming. So instead of having them happen one after another, they are now in parallel. All right, so what we want to do then is draw a line from here to hello, and from the say to the end, as well as the hello from the end. So now, instead of sending one signal out from the start, we're going to send two signals out. So now we're going to do both at the same time. Now, pay close attention to this. So we're going to go ahead and hit play.
Hello.
Okay, so the robot actually froze mid-hello. Now, anyone have an idea why that happened? Yes. Yes.
It stopped both at the same time since it's supposed to be running at the same time. It also stopped them both at the same time. So when the robot finished saying hello, it stopped waving also. But
Yeah.
midway.
Yeah, exactly. So for those that didn't hear on the stream, she was saying that because these are hooked up together, these are going to play at the same time, which is good. That's what we wanted to happen. But the problem is this will stop our program no matter what. Think of it like an automatic shutdown for your computer. If you are having something trigger this, something that's sending a signal to that, it will stop the robot no matter what else it's doing. So at this juncture, we're having the robot say hello and wave hello at the same time. Now, it takes a lot less time to say hello, and so it's getting finished, and then it's sending a signal here. So this is stopping the program while we're in the middle of this box, which is not really what we want it to do. We want it to do both, but not get interrupted by itself. So there's an easy solution to this. We can go ahead and get rid of this. We know that it takes longer to say hello than it takes to wave. So if we go ahead and do this, robot says hello, triggers the output there, doesn't do anything because it's not hooked up to anything, and then the hello finishes and sends a signal telling the program to stop. So let's just do that one more time so you hear that.
Hello.
Okay, so this is a nice solution, but only to an extent. Say, for example, you're working with more custom boxes than this. You don't know necessarily what the time is for box A and box B are to complete. And you don't want to have to guess and test every single time. So we want to introduce a piece of logic, and this is where we're going to get into the Python itself. So every time you need to make a logical determination in your code, you're going to use something in the Choreograph box library called flow control. Flow control is, like I said, kind of like a logical determination. It lets you make decisions based on other factors that the code will figure out itself, so you don't have to. So we're going to use a box in here called wait for signals. Now, if I mouse over this, it'll say waits for both inputs to be stimulated before stimulating its output. Now, what that means is it's going to take two inputs, and it's going to wait for both of those inputs to be there before stimulating its output. So if I go ahead and test this out, we'll see that the wait for signals box gets one signal sent in here, It then waits until the hello box sends a signal, and then it finishes up. So let's just see that one more time.
Hello.
So watch right here, signal gets sent in here, and then it sends the output. So that's your first bit of logic that the robot uses. So that's kind of nice. Again, we're still only working with the boxes, so we want to have a little more sway. We want to have a little more to do with inside the code. We want to say, what are we actually learning from this? So what I want to do is actually edit this box. So there's a number of things you can do to learn Python, to work with the Python. I mentioned you can look at the Python inside boxes. You can take that. You can edit it yourself. You don't have to leave everything the packaged way that it is. Now, if you want, we can look at this inside the wait for signals box. We see a little script editor, and this is the bit of logic that makes that box do what it does. Now, I'm going to go through this because I want to make this different. I want to have the robot do a number of different things at the same time. Let's say I want the robot to wait for 3 different signals. So if I'm looking at this, I say, well, I can't have this wait for 3 signals because there's only 2 inputs. So these little squares on the left, those are the inputs that you have to stimulate before your box can make its logical determinations. So I want to edit this so that it's not only going to wait for 3 signals, but it's going to have the inputs available for it. So what I'm going to do is I'm going to right-click this, and I'm going to edit the box. So edit box script, that's going to pull up the script editor that we just showed you. Editing the box will let you change the number of inputs and outputs. So right now, I can see for under inputs here, we have signal 1 and signal 2. Those are the only 2 options. Now we're going to go ahead and hit this plus sign. We're going to make our own input. So just to follow the same naming convention, we're going to call this signal 3. If we hit OK, we see there's an additional box here. If we mouse over that, that's signal 3. So what I want to do with this is then go into the code and write a little something extra so the robot can then take another third action and figure out what's going to take the longest of these 3 things and wait for all 3 to finish before going in. So in order to do that, we kind of have to understand the code inside this box. Now, we saw an example of how this works. It's going to take 2 signals, whichever one takes longer, it will then send an output once both are received. So let's go back inside of this. And this is going to be a little bit of our first foray into the actual coding syntax for Python. Now, we're kind of fortunate because Python is a much more readable language than most languages out there. It's very kind of English-based, where if you can imagine it, the way it's logically in your brain should look, Python is about as close as it gets in terms of programming languages. Everything that you can do is often separated by indentations and defining based on the most logical way that we do in English. So when we pull this up, we see this is what the box came with. This is the code that is inside the box when it's only for 2 signals. So I'm going to go ahead and dock this over here for now. Get rid of that. And we're going to look at exactly how this is working. So at the top here, you'll see class, my class, generated class. A lot of this stuff is kind of a prepackaged skeleton. This is the stuff that makes the box do what it does, kind of at a base level, where it's not really necessary to understand the full, the full practice of writing this all out, because oftentimes when you're creating boxes, it'll have that general exoskeleton for you. So if I go to a brand new Python script and I look inside it, this is kind of the automatically generated inputs and outputs and the general structure. So without worrying too much about that, because you can always pull up a box and see what is inside here. So I'm not going to go over exactly why we use all of this. Just understand that this is the best way for these boxes to be set up. So if we want to use this as a rubric, as a nice template, we can kind of take a look and see how these things are defined. So define def on load self. What this is saying, and keep in mind, everything that has a a little hashtag here has with green text, that's a comment. That means it's not actually part of the code. It's just there so you can read it, so the programmers can pass a better idea of what the code does onto you. But this is not actually executing any code. So on load, put initialization code here. That means when you load the box, without even sending an input to it, it's already going to do something here if you want it to. It's not necessary, but you can. Pass, that just means we're not doing anything with this box in this situation. On unload, this is put cleanup code here, so when your program finishes, if you need to do anything else, then when the program ends, you can put that code here. On input on start, that's going to be your start here. So when you pass the signal into your box, this is the code here. And then on stop, this will stop the box, it'll unload it, and it'll trigger your onStopped command, which is right here. This is your output. Are there any questions about this so far? Mm-hmm. No, you don't have to take this out. This is just an example. That you can use this again if you want to as a rubric, if you want to understand the base code for it, but you don't have to. Yes? Oh, sorry. Yeah, go ahead and repeat that.
What does my class mean exactly, though?
Well, this is just the way of introducing this box. So this is basically, we call these functions classes, and this is kind of how you define it. Yes?
Is there a Python like learning another language?
So she asks, is Python like learning another language? Do you mean like French or Spanish? There are parallels to it, yes. Think of how you have to learn rules for grammar, learn rules for how you arrange things differently than English. Every programming language has a way that you have to organize the structure. So think of programming like making sentences. There's a certain way about doing it. The only difference is if you mess up in programming, your program might not work, versus if you don't say the right sentence in a foreign language, then you might not get the right idea across, but people can kind of understand you. Yes? Yes, is that a question, or you? Okay. All right, so again, without getting too hung up on all this, because you can always go into if you ever want to pull this up, you can either go into the box library templates, pull out Python script, and you can see this, or otherwise you can go, if you right click in the programming area, under create new box, Python, you can name it whatever. So example, you can set inputs and outputs. If I double click that, it's going to show me the exact same thing. So you're never too far out of arm's reach of finding one of these boxes, of finding kind of how it should be set up from the base. Now, it's good to have that, but since we're just learning Python, we're not going to know how to program from scratch. So we kind of want to use another example in order to get our feet wet with it, right? So let's go back to the wait for signals. So we're going to use this to learn a little bit of programming and actually make adjustments so we can, again, wait for 3 signals if we want. So when we're loading the box, we're going to see a couple different things here. So when we're defining this onload for the box, we're going to set self.ok equals open bracket false close bracket times 2. Now, what does this mean? This is actually creating an array. Do people here know what arrays are? Good. So for those that don't, arrays are basically creating a list of things. So you're creating, in the programming world, an array is something that you can organize data in. So let's say, for example, I wanted to keep track of the different animals in a zoo. I could create an array called self.zoo and have it equal to open bracket penguin, comma, koala, comma, tiger, et cetera, until I end that with this closed bracket. That's creating that list of animals so that I could then pull up that array and gather information. I can pull specific information from that for my code somewhere down the line. Now for this, what it's doing is it's setting an array. We're making an array called OK, and we're going to set it to false. And this times 2 means that we're creating 2 elements. So we're creating a 2x1 array that has the values false, false. Now this is not going to become immediately intuitive as to why it's set up this way, but we'll get into that once we get down to this code. So when we're unloading the box, we don't really have to worry too much about that. We have a couple inputs here, and then this onStart function. So let me go ahead and mouse over some of the inputs. So when I go here, if I mouse over this first input for wait for signals, if I can get there. So this is it's called signal 1. So the name here is signal 1. Type is bang. That just means that we're not sending any information. It's just a signal, and it has a tooltip. So the name of that is signal 1. That means the name of this one's signal 2, because we're waiting for 2 different signals. That's what these are. These define these little functions here on input underscore signal 1. That refers to what happens when this gets a signal. So when the robot finishes saying hello, it's going to send a signal into signal 1, which will then execute this block of code, which will execute on input signal 1, and then it's defined as self. And what this does is it runs this other function. Now it doesn't look like a whole lot. You're saying, well, what is this? It's just on start and then 1. But we'll get into that. The signal 2 here, that's our second signal. Again, that's going to be defined right here. So when the robot finishes saying hello, it's going to send a signal into signal 2, which will then trigger this. It'll run this block of code, which then runs this on start. Now, there's no input here for on start. So what that means is this block right here, there's nothing on there, nothing on this box that is actually being triggered by that. So this is entirely self-contained in this code. So when we run the signal 1, it's actually going to run this itself. It's going to say run on start, and it has open parentheses 1, and this for signal 2 it has open parentheses 2. What this means is it's going to run this block of code with a specific input. So when we're running behaviors, when we're running programs, there's different ways of setting up signals and functions, classes, however you want to define it. And normally, so for something like this, we're not sending any information. We're just saying this is a signal. There's no data associated with it. So that's why they only say self. So this open parentheses self close parentheses means there's nothing that there's no information that this needs in order to run. Now this, on start, it has self, comma, and input. Now that means it actually needs some information. It needs a little something extra. So that's why when we're running this on start needs to pass the information along. So when you're running an extra class here, when you're calling something, if it needs an input, you have to supply that information. And in this case, it's supplying the information 1. So when we're saying on input signal 1, self.onStart1, we're actually saying run on start where n input is equal to 1. So and for the same token, but down here, if we're saying if we touch this signal, if we send a signal here, we're going to run this on input signal 2, which is then going to trigger this where n input equals 2. So basically, no matter which one of those you trigger, you're running the same block of code. You're just sending, either n input equals to 1 or n input equals to 2, depending on which one of these you hit. So going from there, all we have to do is understand how this block works, and then we're already there. We already know how this block works in Python. So first thing it says, self.ok, and then it has open bracket n input -1 equals true. So remember up here we defined our array as false, false. So let me just go ahead and pull up. Let me think. I think I have. So I'm going to go ahead and pull up Excel just to kind of represent this. So when we have our array, it starts out as false, false. That's what this onload self.ok false squared is, or false times 2. It's not quite the same. Go ahead and open this. So think of this as self.ok equals false for the first value, false for the second value. Now, as an array, this has specific ways of accessing that information. So the first element of an array is going to be accessed by saying pull element 0. Now, this is going to be kind of counterintuitive, so it's important to pay attention to this. If you're accessing information, you actually start at element 0 as opposed to 1. So for example, if I wanted to see what this value, if I wanted to pull what this value was, I would say self.ok bracket 0, or open bracket 0, close bracket. So this is kind of how you get from that to that. Now, if I want to see what the second value is, the second element, it would be self.ok, open bracket 1. So what this is saying is if I define my array as false, false, this is going to be the first value, which is false in this case, and the second value is false in that scenario. So why do we arrange it like this? I don't know. That's just kind of how programming has been defined for years and years, and it would be too confusing to change now. So that's kind of why it's like that. Let's go ahead and switch the power chord there. You got it? Okay. So we're going to go back to Choreograph. Now I bring this up because it says our first bit of code, once we get to this onStart box, is self.ok and input -1 equals true. This is a little bit confusing because we're not sure maybe necessarily why this is like this at first. So anyone understand what this block of code does, what this line here is saying? Any ideas? Yes, in the hat.
No.
All right, so well, what about wait for signal? This is the wait for signal box. This whole text of code, this whole thing. Is there anything specific about it? Okay. Yes.
Wait for signal on input 1, maybe?
Okay, so wait for signal input 1. Well, that's true. If we're triggering input 1, then we're going to have this change something for input 1. All right, last one.
Like, so n input, like, represents both of them going at the same time, and then -1 means, like, once the 1 gets there, like, to get it out of the scene and wait for it, or wait for 2 to come. It's sort of hard to explain. Like, I think that's what it means. Like, it means, like, both of them, and then but then the -1 means to wait for the 2. Well, I mean, for 0, I think.
Okay, so it's close to that. I think I see what you're saying. So basically, the reason this is set up this way, so when this information is being sent, you know, when we hit signal 1, we're sending the number 1 into this input. So n input equals 1 in this case. Now, if n input equals 1, what is self.ok? What is this value here?
0.
Right. So that's saying self.ok bracket 0 bracket equals true. So what is that doing for our array? What is that saying? Yes.
At location 0 and asking you for the input at that particular location.
Okay, so you're saying it's setting the pointer. So the pointer, think of the pointer as, you know, you're saying I want to look at this value here, and you're saying this is the pointer for this part of the array. So this array that we define when we load the box, that's what this is going to look at. It's going to say, okay, if n input equals 1, then this is 0. You know, 1 minus 1 is 0. I think we can all agree on that. Self.ok 0 it's setting this equal to true. So the reason it's doing that is because once we hit the first signal, we can change this array. And basically what this is saying is self.ok represents what signals have been sent. And if signal 1 has been sent and it's then setting self.ok, let's just say set this equal to 0, it's basically saying this, self.ok 0 equals true. Now I don't want to leave it like that because then it's not going to work. Now if I go back to here, this is self.ok 0. So that's the first element in the array. So what it's saying is, instead of being false, it's now going to make that true. Right? That makes sense? Okay. So something that's kind of tricky to keep in mind is this array is not actually seen by anything outside the code. So nothing over here or nothing over here has anything to do with this self.ok array. That's all sitting inside this box. And the whole reason that that exists is so the code can make that logical deduction on how these signals are being managed, right? So when we're looking at this self.ok, all you need to look at is what's inside this box. All this does is it kind of keeps an internal tracking for how these signals are defined. So think of this think of this kind of in terms of your own brain. If your brain is saying hello, you're gonna internally recognize that you say hello faster than you wave, but you don't just stop mid-wave once you say hello, right? You continue. So you kind of have this internal tracking of, okay, I finished saying hello first, but I'm going to keep waving because that's the normal, non-awkward thing to do. So this self.ok, think of it like the internal thought that you have that says, okay, I finished that, but now I have this other value. So that's what this is doing. It's also going to set b output equal to true. So it's basically defining a new variable here, b output equals true. Now, this next line of code is what we call a for loop. So for those of you who are veteran programmers, this is going to be super reminiscent. But for new people, for new to coders, this is going to be a very important lesson. So a for statement is something that does a piece of work for basically every option in that series. So again, in the Python language, this is defined very easily. We have a for statement, and everything that's in Python that is a piece of code, everything that has to do with logic is actually colored differently. So def, for, if, in, false. These are kind of bolded and blued for you so you know that this is kind of the way the syntax should look. So the way a for statement is set up, you say for, that's how you introduce that you're going to use a for statement. You define it, you create a variable. So a variable is just something that you're going to store information in. So just like we stored the values for false and false in this array OK, we're going to say, kind of keep this temporary value, be OK, and it's going to look at everything in this array. So for be OK in self.ok is saying, examine each element in this array. This array, how long is this array? 2, right? So the array is two elements long. It starts out false, false. Now we know that it's setting it to true here if we hit our first signal. So what this is going to do is it's going to say, look at every element in this array. So look at both element 1 and element 2. In other words, look at self.ok 0 and self.ok 1. Those are the 2 elements. This is just a way of kind of consolidating that, so we don't have to type out look at array element 1, look at array element 2, because when you're working with much larger arrays, you'd much rather have the computer do the work for you to go through and iterate that many times. So when we get to this point, we're going to look at the first element in self.ok. What this does, it's going to set b output equals to b output and b OK. Now this might be confusing because you're saying, how can this equal that and that? So the way this statement works is you're setting this to this and this. So think of and statements as a way of making a determination of a group based on the details. So when 2 things are true, that means when you and them together, then the result is true. If either one of them is false, then the result is also false. So think of this like a Venn diagram. I don't know if you all know what a Venn diagram is, but let's go ahead and pull. I'm going to draw a very quick representation here. So imagine you have a group of people that are, let's classify them as group gray, and we have a group of people that are classified as, let's go ahead and get rid of that, group yellow. So we're going to set it up like that. Then we're going to say, or let's say orange and gray. So let's say we have two groups. We have a group that fulfills, we'll set that as green. So let's say this represents groups of people. So groups of people that say, for example, like ice cream are gray. And then let's say people that are in orange represents people that like pizza. So ice cream, people, or ice cream, pizza. Now this green area, that's going to represent the people that, what? Like ice cream and pizza, which should be everyone, I would hope. But this is green. So what this means is this is the people that like ice cream and pizza. So if we're looking at the people that like ice cream or pizza, what would be represented here? Who is represented by the people that likes ice cream or pizza? Yes. No, that's and, so that's both people, because this is the group of people that is inside both of those. Yes, so it's everybody. So if you're taking if you're saying I like ice cream or pizza, then you're looking at this entire thing. Now, if I say ice cream and pizza, you know, I look at, well, these people like ice cream, but they don't like pizza. These people like pizza, but not ice cream. This is the only area that makes sense. So that's my very brief introduction to and or statements. So from a programming perspective, that's why we use and or, because just intuitively it makes sense, right? We can conceptualize when things either fit into a group or do not. So be output, it's setting that to be output and be okay. So keep in mind that this is inside a for statement. So every time you create a for statement, you define a statement that you want to do iterations on, you have to look at the indentation. Everything that's indented on the next line, that's inside the for statement. So inside here, we're looking at just this one line. So we only have to do one piece of code. That's pretty easy, right? We can do that. So we're looking at the first element in self.ok. So keep in mind that we just changed it to true. So if we go back to our Excel, let's just, we're keeping track. We have true, false, right? So self.ok is true, false here. So for the first element, that's true, right? So the first element in self.ok is true. So that's going to say be okay is true here. So we're going to say be output equals be output and be okay. Be okay we know is true. That's the first element in our array that we just changed. Be output, that's true. So when we say, converting what we know about and or statements from the example to this, if it's true and true, then the result is also true. If it's true and false, or false and true, or false and false, then this is going to be false. It has to be, both have to be true in order for this to be a legitimate statement. So the first iteration of this says be output is true, right? Because be okay is the first element is true, and be output is still true. Now we're going to go to the second element. So since we're in a for statement, we have to look at the next element. We have to say, all right, well that we can see is false. So if we look at this, now be okay is false. So then be output equals be output and be okay. Be okay is now false in this situation. So we have this be the result of true and false. So what does that make our be output now? Right, it makes it false. So we're looking at this, And this is actually, the reason they set this up this way is because it wants to go through every element and figure out is every part of that array true. And in this case, it's not. So then we're going to say if b output, and then close parentheses. This is another piece of logic. If saying, basically says if this is true, run this code. If it isn't true, then don't run it. It's that simple. So we're going to say, after we finish this for statement, b output becomes false. So it says if b output, well, it's false, so we're not going to run this. But let's imagine, yes. So it's defined in the for loop. So she asked, where do we define be okay? Be okay is defined in the for loop. It's basically saying for each element in the array. So think of this just as when you're going through the loop iterations, this is the current value that you're at. So it's either going to be the first element of self.ok or the second element in this situation. So if we run output or input signal 2, it's going to pass along this information self.onStart2. The first thing it's going to do is what? What is this block of code going to do if we have self.input as n input equals to 2? What is this going to do to our array? Okay, so what this is saying is I'm going to take this 2, I'm going to say n input minus 1, n input equals 2 in this case because that's the value we're passing along. It's going to set this equal to 2 minus 1 is 1, so it's saying self.ok 1 equals true. So what is that saying? It's saying this array that we created is now going to be, so this self.ok 1, that's our second element. We're now setting that to true. So using that, so now that we have our second element set to true, we can run through this loop again. We're going to set b output equal to true again. We're going to say for each element in self.ok, we're going to say b output equals the and statement. So true and true, because the first element is true. This is going to remain true. Second element, this is going to say this is equal to, again, true, and the second element also true. So now b output is true in this case. So after the loop is done, if b output, that means if it's true, then run this code. Are we going to run this code now? Yeah, because it's now true. So what this is saying is self.ok equals false times 2. So it's doing the same thing that when we loaded the box. So basically it's resetting the values. It's resetting that array from true true to false false. And then it's going to say self.signals received, open parentheses, close parentheses. What this is doing is it's saying this output, if I mouse over it, this is signals received. So in other words, this is actually how we run that. So this, you might wonder how internally is the code going to make this go from there to there? Well, if you just look at this, it's saying signals received, open parentheses, close parentheses. Again, we're not passing any information along with this. So in this scenario, we're passing either 1 or 2. In this case, we're just sending a signal. So that's how we set that up. So I know we're about out of time here, but I want to quickly go over how we convert this to a wait for 3 signals. So first of all, we've defined our third signal. We've created an extra input. So what I'm going to do is actually create another one of these. So I'm just going to go ahead and create a defined signal. So we're going to create we have one for signal 1 and signal 2. We're going to create one for signal 3. And instead of passing 2 along, we're going to pass along 3. So we have to modify our code just a little bit more, right? We have now 3 elements that we have to keep track of. So we're going to define our array as 3. So it's now 3 elements long, and it's going to iterate for all 3 of them. So it's as simple as that. I know I went over this quickly, but we've basically added an extra input. So the input that we're going to be stimulating third, that's going to go here. this self.ok, now instead of being a 2-element array, we're going to look at a 3-element array. So we're going to say self.ok is false, false, false. That's to start. And this is going to be represented by self.ok2. So again, third element in the array is going to be referenced by 2. So, all right, let's test this out real fast. Let's have the robot. I'm going to have the robot blink a bunch. How about that? So, blink loop. So we're going to pull that in. And so I made this box earlier. Basically what this does is it has the robot blink a certain number of times based on a counter. It's going to blink 5 different times after waiting. So actually let me have the robot stand up first before I do this, just so it's easier to see. So I'm going to create a little stand box, hit play. Now it's going to be kind of tough to see, so try to keep track. The eyes are going to blink. They're going to blink 5 times. The robot's going to wave, and then the robot's going to say hello. So let's go ahead and draw our lines here. Again, you can draw any number of lines and run any number of things in parallel at the same time. Let's go ahead and double check this, and I think we're good to go. So let's go ahead and hit play. So you see the first signal got sent, hello gets sent. So now we're just waiting on the blink loop to go. Signal gets sent, and then our wait for signals box successfully triggers, and then they're all set. Now let's go ahead and say, well, just for posterity, I want to make sure it's not timing based, so I'm gonna switch these boxes up. So this is now number 2, and the hello is now number 3. I want to make sure that this works for all cases, and it's not just a freak accident where it only worked because I had 1, 2, 3 in order.
Hello.
So again, we see the robot say hello, triggered, wave triggers, and now we're still waiting for the blink. All right, so I think you can all see. We'll do that one more time just in case.
Hello.
So I'm going to watch here. I see the say triggers. Hello's going to go in here. And now we're just waiting for blink, and that's going to trigger this at the same time. So that is then taking all that information. So even while this is all happening, this block of code is running all of these mathematical deductions. It's doing all these different lines of code in that short period of time. So the moment this signal gets sent, what it's doing is it's triggering this on input signal 3. It's going to pass that 3 along to here. It's going to say an input, well, I guess, no, so, sorry, this is signal 2 now since we switched it. So it's going to say signal 2, it's going to pass 2 here. It's going to say this element is true. It's going to go through this for loop. It's going to go through every single one of those elements of the array, and then it's going to say, okay, well, we've seen all this data. We've set them all to true. We know that now, so we're going to say, we're going to reset this element array back to false, and we're going to trigger our output, which is done here. Are there any questions about this? Yes.
I have a question about just the piece that you put in there, the link loop.
Yes.
That was kind of like a compound, like you created one of these and then you put it into that so it became a single one?
Yes. So.
Did you create it originally with Python or through the pieces on your left?
Okay, so yeah, good question. So she was asking about this blink loop. This is something I created myself, and she was wondering, inside of it, it's made up of other boxes. So to answer your question, no, I didn't create this with Python itself. I created this as a diagram box. So when you create a box from scratch, there's different ways of doing it. You can use an animation box. So an animation kind of looks like this, where you have a timeline up there. You can use a Python script, which is what we've been working with recently, or you can use a diagram, and a diagram is basically an open slate, so you can create a combination of other boxes that are in and of themselves other types of boxes, either timeline, diagram, or Python. So if I wanted, I could actually convert this all into a box. So if I right-clicked, convert to box, wait for 3, say wait for 3. So now, if I look inside, so this automatically creates a number of boxes inside this wait for 3 box.
And then that goes on the side as one of your personal boxes that you have.
It doesn't have to. I can save it as such. That's what I did with the blink loop. They're not saved by default, but you can save any number of them to your personal library. Yeah.
Thank you.
Mm-hmm. Anything else? Yes.
Are there any debugging features for this side?
Yes.
Python? Like, can you set breakpoints or watch variable values or anything?
Yeah. In fact, here I'll intentionally crash this. Let's say I don't define this, and something like this. If I'm set the wrong type of value here. All right. So when I run my program, I intentionally put a piece of code in there that doesn't work. Now, normally when you have to debug, hopefully there's a little bit of a way of narrowing it down what went wrong. In this case, it'll show you on the top here, this turned red, and the wait for signals box turned red, so that we know that there's a problem wrong with that piece of code. And not only that, but this box illuminated, this is our debug error output box. So this is our log viewer. We can actually see exactly what went wrong. We can see, we can set the information to watch for certain types of logs. So info, warning, debugging. So there's a pretty good way of debugging your code using these different options. So what this is saying is there's a syntax error, and it's basically pointing me to the line that I added the incorrect line of code in. So then I can go through there and say, oh, well, okay, I didn't know that was the wrong way of doing that, and I can change it back to what it was.
So that's kind of like a compile error. But does it let you see stuff at runtime too? Like, can you actually watch?
Yes.
The way you can watch the little color traces on the threads to the left, can you watch over here as it executes each line of code, or?
Yes, yeah. In fact, if I pull that menu back up, let me see. Let me pull up the debug. So let me just run this one more time.
Hello.
So right now I can show all the logs. And you can see actually the different information that's being passed.
Hello.
Is that good? Okay. All right. So I think that's about it. I'd like to thank you all for joining us. I hope you learned a lot. Hope this has been a successful introduction to Python or coding in general for you. I know a lot of you have been working with the robot already, so I really encourage you to play around with this. Look online. There's a lot of free tutorials for how to learn Python, how to hone your skills with it. So keep at it. Keep looking at boxes in here and try to learn the Python with the robot and create some really cool behaviors with that.
I'd like to thank Aldebaran and Jack for presenting tonight. I know that many of you will be back for a level 2 training, and I noticed in the group that we have many levels, don't we? Python, tonight you had Choreograph, where Choreograph is fairly easy. But once you get to Python, and false, true, true, false, 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 true, false, false, it gets a little more complicated. So we're going to have some Python classes in the future, too, to break it down into smaller bits. I'd like to thank all the people that are out there watching us live for viewing tonight. And look, they brought a special certificate. And believe me, if you should get this certificate, it's in the back. You can see Alex in the back holding it up. So you get a certificate for completion of having gone through the hour of code with Aldebaran tonight. So please take your certificate. And also, there's a lot of other information back there about Aldebaran and about coding. Okay, thank you for being here.